Where are all the aliens? Let's talk about it. Picture this. You're standing in a field at night, looking up at the stars. What you're seeing feels vast, but it's barely anything. The observable universe stretches across 93 billion light years, containing up to 2 trillion galaxies. Each galaxy holds hundreds of billions of stars. In our Milky Way alone, there may be 40 billion Earth-like planets, places where liquid water and possibly life could exist. The numbers quickly stop meaning anything. If you tried to count every star, one per second, it would take longer than the universe has existed. We're talking about 20,000 billion stars. Each one a chance. Each one a potential beginning. And this cosmic system has been running for over 13 billion years. That's enough time for civilizations not just to emerge, but to rise, expand, and spread across entire galaxies. Some could have even had a billion-year head start on us. So when you really sit with this, the scale, the time, the sheer number of opportunities, something starts to feel wrong. Because when we look out into the universe, we don't see civilizations spreading across the stars. We don't see vast structures. We don't see signs of intelligence. We see silence. It's like walking into a city the size of a planet and finding every street empty. This is the heart of the Fermi Paradox. The universe looks like it should be full of life. So where is everyone? But maybe that's the wrong question. Maybe the real question is, what exactly are we looking for? When we say we're searching for aliens, what do we actually mean? The word itself is almost useless. Somewhere out there could be civilizations just discovering fire. Others might be at our level, building satellites, sending signals into space. And some might be so advanced that their technology wouldn't look like technology at all. But we're not just searching across space. We're searching across time. When we look at a star system 1,000 light years away, we're seeing it as it was 1,000 years ago. Any civilization there could have risen, advanced, and disappeared before their light even reached us. This creates a kind of cosmic misalignment, even if the galaxy is full of intelligent life. The chances of two civilizations overlapping in time at similar levels of development and close enough to detect each other might be incredibly small. But there's another problem. We're searching, using ourselves as the template. We look for radio signals because we use radio signals. We imagine cities, industry, expansion, because that's what we've done. But intelligence doesn't have to look like us. It might not build cities. It might not expand. It might not even communicate in ways we would recognize. So how do we search for something we don't understand? We need a framework, something that doesn't depend on biology, culture, or imagination. Something universal. And there is one thing every civilization must obey: the laws of physics. Which means there is one thing every civilization must deal with: energy. Energy is the currency of civilization. Every major step forward in human history has been about accessing more of it. We started with muscle, then fire, then wind and water, then fossil fuels, then the atom. This pattern is not uniquely human. Any civilization that builds technology must solve the same problem. How do you extract energy and use it to do work? In 1964, astronomer Nikolai Kardashev proposed a simple idea. You can classify civilizations based on how much energy they can use. This became known as the Kardashev Scale. A Type 1 civilization can use all the energy available on its home planet. It controls its climate, its ecosystems, its resources. Nothing on the planet is beyond its influence. A Type 2 civilization can use the energy of its entire star, not a fraction of it, all of it. A Type 3 civilization uses the energy of an entire galaxy. Hundreds of billions of stars, all harnessed, all controlled. Type 1 to Type 2 is like a campfire compared to the sun. Type 2 to Type 3 is like a single star compared to the Milky Way. So, where are we? Humanity is not even Type 1. We're around 0.7. We've reshaped parts of our planet, changed the atmosphere, redirected rivers. If we survive and continue advancing, we might reach Type 1 in a few hundred years. But here's the key point. Any civilization that reaches Type 1 doesn't stop. The same forces that got them there, curiosity, competition, expansion, push them outward. Once a civilization masters its planet, the next step is obvious. First, outposts. Then, colonies. Then, industry in space. Eventually, entire planets could be reshaped, their atmospheres altered, their surfaces engineered. But even a fully developed solar system has limits. If a civilization keeps growing, it will eventually face a hard boundary: its star. And that's when things become different. Instead of living on planets, a civilization might begin to build around its star. Not a solid shell, but a vast swarm of structures. Millions or billions of collectors, capturing sunlight and converting it into usable energy. A Dyson swarm. From the outside, the star would dim, its light partially blocked, its energy re-emitted as heat. This is what a Type 2 civilization looks like. Not cities, not nations. Infrastructure on the scale of a solar system. At this point, a civilization stops being a species and starts becoming cosmic architecture. With the full energy output of a star, the next step is other stars. Expansion becomes interstellar and eventually galactic. A Type 3 civilization wouldn't just explore the galaxy, it would reorganize it. Stars would be harvested, systems reshaped, entire regions engineered for energy and computation. From a distance, their galaxy wouldn't look natural anymore. It would look designed. And this is the crucial point. We should be able to see this. Even a single Type 2 civilization would leave detectable signatures. A Type 3 civilization would be impossible to miss. The sky itself would look different. But when we look out into the galaxy, we don't see any of it. No dimmed stars surrounded by megastructures. No vast energy signatures. No regions of engineered space. The Milky Way looks natural, unmodified, quiet. This absence tells us something important. If civilizations commonly reach Type 2 or Type 3, we would know. Either they are extremely rare, or something stops them. Maybe the leap from planetary to stellar civilization is far harder than we imagine. Maybe most civilizations don't survive long enough. Maybe intelligence itself is rare. Or maybe we're wrong about what advanced civilizations do. Maybe they don't expand outward. Maybe they become smaller, more efficient, less visible. Or maybe we're early. Maybe we're among the first. Not late to a crowded universe, but early to an empty one. Living at the beginning of a story that hasn't fully unfolded yet. The truth is, we don't know. We've been searching seriously for only a few decades. We've examined only a tiny fraction of the galaxy. And we've done it with tools that are still primitive. The silence might not be permanent. It might just mean we haven't been listening long enough. Or in the right way. Or for the right things. But one thing is clear. We're still at the very beginning. Not even a Type 1 civilization. Not even fully visible. On a cosmic scale, humanity is almost invisible. So maybe the real question isn't just, where is everyone? But also, would anyone even notice us? And if the answer is no, then perhaps the silence isn't surprising at all. Because if civilizations do survive long enough to spread across the stars, they may not announce themselves. And until we reach that level, we may not even understand what we're supposed to see.